This video discusses sinking funds. And a sinking fund allows us to periodically set funds aside to be later used for repayment of a loan or for future expenses. So for the next set of problems, we're going to find the periodic payment or the payment needed to place in an account in order to achieve a specific future value at a later date. Find the amount of each payment needed to accumulate $750,000 in a sinking fund. Assume that the amount earns 15% and is compounded annually for 30 years. To find the payment needed, we're going to use the formula listed on the screen, and P in this case is the amount of each annuity payment. FV is the future value or the total amount needed. I is the interest rate, and N is the total number of compounding periods. So first we'll identify the values for FV, I, and N. So FV is the future value or the amount needed in the future, and we want to get a value of $750,000. So our goal is after we deposit all of this money for 30 years, after 30 years, we want $750,000. So FV is $750,000. I is the interest rate per compounding period. So 15% written as a decimal is 0.15, and then we'll divide by the number of compounding periods, which is 1 since it's compounded annually, so we'll just leave that as 0.15. N is the total number of compounding periods, so we'll multiply how many times it's compounded a year, which is 1, by 30 for 30 years, so N is just going to be 30. So we're going to substitute these values into the formula and solve for P. In order to solve this formula, we first want to add 1 plus 0.15 in parentheses. Next, we'll raise 1.15 to the 30th power. And we get a value of 66.21177,196. And we can keep that number in our calculator and then just subtract 1 from it. We get 65.21177,196. Next, you can keep that number in your calculator and then just divide by 0.15. And we get 434.7451464. Now you'll need to write that number down on a sheet of paper, clear your calculator, and then we'll do 750,000 divided by 434.7451464. When you do that calculation, we get a payment, not present value. These should all be just a single P, since we're looking for the payment needed. So our payment, when we divide those two numbers, is $1,725.15. So if we deposit that into an account that earns 15% compounded annually for 30 years, then we should get $750,000 after 30 years. A restaurant plans to open a second location in 4 years at a cost of $3,500,000. A sinking fund has been set up with the intention of making a payment at the end of each 6-month period. Find the payment needed if the account earns 8% compounded semi-annually. We're going to use the same formula as the problem before. We're going to calculate the periodic payment needed to accumulate the future value, which is represented by the formula on the screen. First, we need to identify the values for FV, which is the future value or the total amount needed, I, which is the interest rate per compounding period, and N, which is the total number of compounding periods. So the future amount, or the total amount needed, is $3,500,000. I, the interest rate per compounding period, is 0.08, and we're going to divide that by 2 since it's compounded semi-annually. And 0.08 divided by 2 gives us a value of 0.04. And finally, N is the number of times it's compounded a year, which is 2, by the number of years, which is 4, so N will be 8. And we'll just take those values and plug them into the formula. When we plug those numbers into the formula, we get the equation on the screen. Now the first step is to add 1 plus 0.04 in parentheses, and we get 1.04. Next, we want to raise 1.04 to the 8th power. You should get a decimal of 1.36856,905. Next, we'll subtract 1 from that number. When we subtract 1, we get 0.36856,90504. Then we'll take that number and divide by 0.04. That will give us 9.214222626. And lastly, you'll write that number down on a sheet of paper, clear your calculator, and then type in 3,500,000 divided by 9.214222626, and you should get a final answer rounded to 2 decimal places, and that is $379,847.41. And that is the payment needed to accumulate $3,500,000 at an 8% interest rate compounded semi-annually for 4 years.